What is the difference between observation and interaction in quantum physics? Have you ever wondered how simply looking at something can change what it is? In quantum physics, this idea is at the heart of understanding the difference between observation and interaction. So, what exactly sets these two apart? Interaction in quantum physics refers to any physical influence between a quantum system and another entity. Imagine a photon, which is a particle of light, hitting an electron. This interaction changes the state or behavior of the electron in a continuous way. For example, when light bounces off a particle, it affects the particle's momentum or position. This is a straightforward interaction that alters the system without necessarily providing any measurable information. On the other hand, observation is a special kind of interaction. It leads to a measurement or what is known as the collapse of the quantum system's wavefunction into a definite state. When we observe a quantum system, we are obtaining information about it. This causes the system to behave more like a particle with specific outcomes rather than a spread-out wave. This brings us to a fascinating question. At what point does an interaction become an observation? For instance, if a measuring device detects which slit a particle goes through in the famous double-slit experiment, the outcome changes dramatically. Instead of showing an interference pattern, which indicates wave behavior, it behaves like a particle. This act of measurement forces the system into a specific state, while mere interaction without measurement does not necessarily do so. It is important to note that all observations requiring interactions, but not all interactions qualify as observations. A dust particle bumping into an electron is an interaction, but it may not count as an observation unless it yields measurable information. In quantum theory, microscopic interactions, like photons interacting with electrons, are treated differently from macroscopic observations, such as a camera detecting a particle. This distinction highlights the weirdness of quantum physics. Simply watching or measuring a particle changes how it behaves. Invisible interactions might not have the same effect. It raises intriguing questions about what counts as an observer. Does a virus or a dust particle qualify? How does reality seem to choose a definite state only when we observe it, rather than just interact with it? To summarize, interaction is a physical influence that alters states but does not always produce definite outcomes. Observation is a type of interaction that involves measurement, causing the quantum system to collapse into a specific state with discrete outcomes. This subtle difference is a key aspect of the strange phenomena we see in quantum physics.